Students, in this part of the video, we are discussing about the vector multiplication. Already you learned that what is the vector is and as well as the scalar. I repeat, a vector is a physical quantity which has both magnitude and direction, and it has to obey the triangular law of vector addition. Here in this video, I already told you we are going to learn about the vector multiplication. Actually, the multiplication of the vectors can be done in two ways. The vector multiplication can be done in two ways. One such way is known as the dot product. One of multiplication is known as the dot product, and it is also known as the scalar product. And second one is a cross product, and it is known as the vector product. First of all, we will learn about the dot product, that is scalar product. In later videos, we will learn about the vector product. Now start with the dot product or scalar product. Okay, first of all, we have to understand what is meant by the dot product. It is very simple. Dot product is the product of the magnitudes of the two vectors with the cosine of the angle between them. I repeat, is a product of the magnitudes of the two vectors with the cosine of the angle between them is known as the dot product. To understand this thing, here we are taking a vector, say it is vector A, okay, and we have one more vector, say it is the vector B, and we join the both. As you learn that the smallest angle is the angle between the two vectors, so it is, I told you, is a product of the magnitudes of the two vectors with the cosine of the angle between them here, and also what the result will act along the direction of the first vector. You can understand this very easily. Here is the vector. I am dropping a normal from this one. I think you understood what I am going to do. I am resolving this vector, B vector, into components, and obviously it is B sine theta, okay, and we take one more component. This is here, if we say it is the component, and we call it as the B cos theta. Okay, see this vector B is resolved into two components. Along x-axis it is B cos theta, and along y it is B sine theta. I will repeat, how can we resolve? In previous class we learnt about the resolution of the vectors. If you take it as the xy plane and say it's a position, we are taking a position vector and we constructed a triangle here OAB, and you know that It is opposite and it is a vector, a bar, and we write it as ay and this component as ax. Here from this triangle we know that sine theta is equal to what? AB by OA. AB, we took it as AY by A, that is AY is equal to A sine theta. Similarly, if we take this side, then if we write the cos theta is equal to OB by OA, that is what? OB is equal to AX upon A, that is AX is equal to A cos theta. It is the actual process of resolution of the vectors. We resolved a vector A bar into two perpendicular components. Along the y-axis we set it as the AY and along the x it is AX. And if you write the unit vectors, then it is I cap and it is j cap. That means what? A bar is equal to AX I cap plus AY j cap, or AX is equal to A cos theta I cap plus A sine theta j cap. Remember this. We are doing here the same. We resolve this vector B bar into two components. One has the B sine theta and had B cos theta. That's I cap is the j cap. These are the vectors. According to the definition, what is the dot product of the two vectors, of the scalar product? It is the product of the two vectors. That means magnitude of the vectors with the cosine of the angle between them, and it has to act along the direction of the first vector. See this? Here I am taking the multiplication of these two vectors. It can be done like this. Is the first vector A bar, according to definition, dot B bar is equal to, I said, the magnitude of the vectors, the product of the magnitude of the vectors AB and cosine of the angle between them, AB cos theta. That is what? A bar dot B bar is equal to AB cos theta. We call it as the dot product or the scalar product of the two vectors. Then we will go with the multiplication of these. How we will multiply? Okay, for example, you say a vector A bar is equal to AX I cap plus AY j cap plus AZ k cap. We took the three-dimensional plane. And similarly, B bar is equal to Bx I cap plus By j cap plus already learned that the dot product of the two vectors A bar dot B bar is equal to AB cos theta. Okay, and we are multiplying it. A bar dot B bar is equal to X I cap plus AY j cap plus AZ k cap multiplied with what? Bx I cap plus By j cap plus Bz k cap. We are multiplying these two vectors. Okay, and we have to multiply these terms. But A bar dot B bar becomes AX BX into I cap dot I cap. What's this? The next term AX BY plus AX BY, and see the terms I into J. I cap dot J cap plus AX BZ. I cap dot K cap. Okay, we complete the first term. Then plus AY BX, AY BX J cap dot I cap plus AY BY J cap dot J cap plus AY BZ J cap dot K cap plus AZ BX, okay, K cap dot I cap plus what we have, AZ BY, that is K cap dot J cap plus AZ BZ multiplied with K cap dot K cap is a vector multiplication. Now we have to multiply these vectors. That means the unit vectors. We have to understand what result we yield. If you take what I cap dot I cap, okay, means what? Here you can represent the system like this. The origin, it is the x-axis, say it is x dash, it is y dash as the y, unit vector I cap, at I cap, j cap, and if you consider the third axis, it is k cap and it is k cap. If you watch them closely, you will understand that these vectors are mutually parallel to each other. I cap dot I cap, comma, j cap dot j cap and k cap, okay, and k cap. These are mutually parallel, and we are going with vector multiplication. We know that A bar dot B bar is equal to AB cos theta. Okay, A bar is a vector I cap dot I cap is equal to I into cos theta. Theta is equal to 0. As you know that cos 0 is equal to 1, then I cap dot I cap is equal to 1. In the same way, if you multiply j cap dot j cap is equal to 1 into unit vector, it is 1 into cos 0, it is 1. Similarly, k cap dot k cap is equal to 1 into cos 0, again it is 1. What does it mean? I cap dot I cap is equal to j cap dot j cap is equal to k cap dot k cap is equal to 1. And if you watch these vectors, I and j are mutually perpendicular. I and j are mutually perpendicular, and j and k also mutually perpendicular, and k and I also mutually perpendicular. That means now we are doing what we are doing now. I comma j, okay, j comma k and k comma I are perpendicular. So theta is equal to 90 degree. We are doing the same thing again what we did here. We know that A bar dot B bar is equal to AB cos theta, that is I bar dot j bar is equal to 1 into 1 into cos 90, it is equal to 0. Similarly, j bar dot k cap is equal to 0 and k cap I cap is equal to 0. What does it mean? When the vectors are perpendicular to each other, okay, the two vectors, what? The result is 0. When they are parallel, it is equal to 1. Here we are applying the same values in this relation. Let's see what happens. I hope you understood this one. And we are doing same. Here, by this, you learn that I cap dot I cap is equal to j cap dot j cap is equal to k cap dot k cap is equal to 1, and I cap dot j cap is equal to j cap dot k cap is equal to k cap dot I cap is equal to 0. And we are substituting the values. Here I cap dot I cap, it is 1, it is 0, it is 0, 0, 1, 0, 0, 0, 1. Okay, now the terms will be 0 is multiplied with ay bx and it becomes 0. Then finally we can write it as a bar dot b bar is equal to ax bx plus ay by plus az bz. It is the result what you have to understand. Okay, a bar, we are finding the magnitude of the vectors. If you say take the same relation, first we have to find out A, what is the magnitude of the A, and you know that the vector A is equal to, we said it is axi cap plus ay j cap plus az k cap, means modulus of A is equal to under root of ax square plus ay square